Okay, so I realized I meant to was going to put this up earlier this week, but then I was thinking about it while I was mowing the lawn, and seeing decimals isn't very helpful in this kind of thing because it's easier to see the value, the fractions, and see how things can reduce. So I redid it in Excel. So remember when we do probability, okay, it's the number of events divided by the total number of outcomes. And if things are independent, we multiply those probabilities together. So the probability of getting 2 reds is okay, for some reason it wasn't working. 4 out of 40 times 4 out of 40 because we're replacing that value. If we're not replacing the value, then it's going to be 4 out of 40 times how many are left. Well, there's 3 reds out of how many things are left? 39. Okay. For red 1 or B, a red one and then a brown one, or a brown one and then a red one, well, we have first a red one is 4 out of 40. Times. Then we have a brown one out of a red one, which is going to be 8 out of 40. So that's the first part. The second part is going to then be, we're going to have to then add the second one, which is 8 out of 40 times 4 out of 40. Because, let me make this a little bigger here. Okay, because we're going to do this twice. Now, if there was an intersection of these things, we would subtract them. If this had been a red and a brown, the probability of red 1 or brown 2, then we would have had to subtract out where they have red 1 and brown 2. But we don't have that. We're looking at one thing or another thing and not the total probability. Well, when we do the non-replacement, we're going to have 4 out of 40 times 8 out of 39. And then add to that 8 over 40 times 4 over 39. Oops, sorry. Yeah, 39. Because again, we're not replacing these values. Okay, but we still have all the red ones to go through. Now, red 1 and green 2. Well, we were told that if we have the probabilities are independent, we can, and we have two things, we can multiply them, just like we've been doing with these two things. So the probability of red 1 is 4 out of 40 times green 2, which is 7 out of 40. All right. For no replacement, it's going to be the same thing. We're going to have 4 out of 40 times 7 out of 39. Now, just because we're not replacing it, so the probability of getting green as a second one, because there's 7 greens out of 39 all whole things that are there. Now, G2 given G1, they told us was equal to, if things are independent, is equal to let me rewrite this down here. If the probability of A given B is equal to the probability of A and B all divided by the probability of A. Sorry, probability of B, my fault. The last thing. So here, well, probability of A given and B, well, that's this thing, divided by this. Well, what they then said was that, well, if these things are independent, then the probability of A given B is really equal to the probability of A. Because probability of A and B is equal to the probability of A times the probability of B. Well, if probability of A and B is A times B, and then we're going to divide by B, we get the probability of A. So that just means, well, green is going to be, what's the probability of green happening? 7 over 40. Because it's going to total that. So here I'll write it. It's really 4 divided by 40 times, wrong button, times 7 divided by 40. And I'm going to put all that in parentheses. And all of that is going to be divided by 4 divided by 40. Okay, well, that thing equals 7 divided by 40. Because when we do this out, that disappears. Because we're going to make sure we put that in parentheses so that it knows that it's doing that first. And if I were to put this as a formula instead, you'll actually see that. I put this as equals this. And I want to put these in parentheses again, so we know that the fractions are there, just for our own benefit so we can see them. It equals 7 over 40. Well, same thing is going to occur if we have no replacement. The only thing that's going to change is this value here. This is going to become 7 over 39. Everything else will stay the same. And so our answer is going to come out to be 7 over 39. But what we're doing is we're doing fraction 4 over 40, probability of that, times the probability of 7 over 39, all divided by 4 over 40. And again, we would put in our parentheses so that we can see this as fractions, so it doesn't get too confusing here. There, we see all of our parentheses are kind of holding in these fractions as they occur. There. Oops. There. So those are what the fractions look like, and that should be 39. My fault. Typo. But we can see that if we were to do this, if I put the equal sign in there, that's the math. If I put the equal sign in, I get 7 over 39. Well, the probability of no yellows, that's harder to find out than if we did the complement, which is going to be 1 minus getting yellows. Yeah. No yellows. I'm in cap locks. So this is really, the probability of 1 minus getting yellow. All right. So we have to figure out how many things are that aren't yellow. Well, there's 6 yellows. So the probability of getting a yellow is 6 over 40. So it's 1 minus the probability of getting yellows. 6 over 40. That's the first one. And we then have to find the OR for the second one, which would be 6 over 40. All right. Or if I think it was not getting 2 yellows. I think it was not both yellow. So that becomes the probability of yellow times the probability of yellow. And then we multiply this, subtract it from 1. So and if we were to do this, we would get our answer of 391 over 400. If it was the probability of not getting any yellow, we would have 6 over 40 for the first one and 6 over 40 for the second one, minus the probability of getting both of them is 6 over 40. You know, both of them, so we have to take that part out, and we would have an answer. So if it was just not yellow, okay, that's going to be 1 minus, and we'll put probability of yellow, or y1, oops, probability of y1, or the probability of y2. Helps to put things in the right space, doesn't it? y1 or y2. Okay, which we could figure out. So what you have to do when you're doing probability problems is read what are they asking for. Okay, that's the big thing, is read what they're asking for. And then remember that if they're telling you they're independent, you multiply the probabilities together, each successive one. Okay, it's easier to use fractions than to use decimals because you can cancel fractions, reduce things down. So look for those things. So I would suggest not using your calculator and not using Excel unless you have it for function formatting to put in fractions, and you can do that by highlighting that and saying format fractions. So if I highlight the space and I right click and I do format cells, I can do fractions, and this will allow me to do up to 3 digits in each one. After that it turns into a decimal. So again, you may or may not be able to show your answers as fractions, but this is how you would do that. With the test, the empirical one, you took your data and you plugged it in, and you said, okay, well, we didn't find any of these, or we found 7 of those out of the 24, and so that's what you go with. So I hope this was helpful, and I will see you Saturday.